Why can't dinosaurs talk? Because they're extinct. Okay, so new topic, trigonometry. We're going to blaze through this. Our first topic that we're going to cover in trig is we are going to cover right-angled trigonometry. Okay, anything to do with a right-angled triangle, as a good old friend of mine used to say, there's only two types of triangles now. There's either right-angled or non-right-angled. Okay, so if we're talking about right-angled, you've got two things that you can do here. You can either use Pythagoras Theorem or SOHCAHTOA. Okay, so as I've got here, this is a little bit of a recap of what Pythagoras' theorem is. It's basically saying that the two shorter sides, if you square them together and add them together, you'll get the square of your hypotenuse, which is that longest side or the side across from the right angle. That's your hypotenuse. And then you also have this thing called SOHCAHTOA, which basically means that these are all your different ratios. You'll have sine, cos, and tan. And SOHCAHTOA is just the way that we kind of memorize what's what. So if I have an angle here, my side furthest away, we're going to call that one the opposite. Hypotenuse is just always going to be your hypotenuse. And adjacent just means your closest side. So that's your adjacent side. So the reason that SOHCAHTOA is a thing, if you haven't heard of it before, is because of this. Now I'm hoping that my pen works. Okay, yeah, we're good. So it's SOHCAHTOA. That's where that comes from. Okay, so you've got your SOHCAHTOA, and we're going to use that later on. Now, there's also a couple other things that you'll need to know. First one is reciprocal identities. So reciprocal, as you remember, just means 1 over, or you flip the fraction. Cosec is 1 on sine, sec is 1 on cos, and cot is 1 on tan. You'll have to memorize these, but there's a nice little way to memorize them. Your third letter kind of gives you that little hint. Okay, so cosec is your sine, sec becomes your 1 on cos, cot becomes your 1 on tan. So your third letter is kind of a little hint there. Now, the other thing that you've got here is you've got your exact values. It just means that you use your surd form and there's no decimals in your answer. And this is the one time where you don't have to rationalize your denominators. Okay, so these are the two special triangles that we're given. You get these in your reference sheet. And you can actually use these to find out all your exact values. So for example, sine 30, I'd go sine is SOH, so opposite over hypotenuse. So sine 30 would be a half. That's your exact ratio. Sine 45, I'll do the same thing. So sine is SOH, opposite over hypotenuse. So it's going to be 1 on root 2. Oops. And sine of 60, same thing. Sine of 60 would be opposite over hypotenuse, which is going to be root 3 on 2. Okay, now you can do the same process for all the other ones. I know that cos 30 is going to be root 3 on 2, cos 45 is going to be 1 on root 2, cos 60 is going to be a half, tan 30 is going to be, by the way, if you haven't yet, give it a pause and see if you can complete the other 3, or go back and see if you can figure out all these other ones. Tan 30 should be 1 on root 3, tan 45 should be 1, and tan 60 should be root 3. Hopefully you got those correct. Okay, moving on. Let's use Pythag here. Let's actually try answer some questions. First things first, find x. That is our hypotenuse. So I know that 4 squared plus 4 squared should equal to x squared. Okay, because x is my hypotenuse. And so in this case here, I know that 16 plus 16 should equal to x squared. That means x should equal to the square root of 32 because I've square rooted both sides. Okay, now don't forget, your Pythagoras theorem does not find x, it finds x squared. So in order for us to get the actual answer, the actual value of x, we're going to have the square root. Okay, for this one here, we've got something similar, but this time we know the hypotenuse and we're missing a shorter side. Okay, so in this case here, I'm going to do the same thing. I'm going to write it as x squared plus 5 squared should give me my hypotenuse squared, which is 13 squared. And so from here, I can see that it's just going to be 13 squared, take away 5 squared. And the way that I do that is just by minusing 5 squared to both sides, making x my subject. And again, this should give me something like x squared equals to, I think it's 169, take away 25. 169 take away 25, which is 144. And from here, that gives me x squared, but I just want x. So I take the square root of 144, and that just gives me a nice answer of 12. Okay, that's how we'd use Pythagoras. Now, another example of a question they may give is find the exact value of, and then they'll say tan 30, cos 60, and then we're starting to introduce some reciprocal identities here, okay? So if I'm looking at tan 30 would be, I look at the 30, I go opposite over adjacent. So adjacent would be your root 3 because 2 is going to be your hypotenuse. So for this one would be 1 on root 3 is your answer. Okay, for cos 60 would be adjacent over hypotenuse. So that's a nice one. That's a half. Now sec, we know that sec is 1 on cos. So we can write it like that. Or in other words, the way that I would think of this is what is, oh, we don't have 45, my bad. Let's change that to maybe, let's go sec 60. Okay. Would need a different triangle for the 45 because there's no 45 degrees in this triangle. So we've got cos, it'll be 1 on cos 60 because sec is the reciprocal of cos, third letter. Okay. Now cos 60 itself is adjacent over hypotenuse, correct? So it should be 1 on 2, but if I take the reciprocal, it's kind of like 1 over a half, or in other words, I just flip my fraction, which gives me 2 over 1, which is 2. Okay. And for cosec 30, it's the same thing. Cosec is the reciprocal of sine. Okay. Third letter, S, sine. So again, I'm going to find sine 30. Sine 30 is opposite over adjacent. There you go, opposite over adjacent. So 1 over 2 would be my regular sine 30. Because I'm taking the reciprocal, I'm going to flip it. So instead of 1 over 2, I'm going to write it as 2 over 1. And again, this is just me skipping steps. If you wanted to do the whole thing, this would be the same thing. 1 over sine 30, which is a half. And that just ends up flipping my fraction upside down. So 2 on 1, the same thing as 2. All right, moving on. We're going to blitz through these. So hang tight here. Finding unknown sides and angles. Angus, who's Angus? Finding the unknown sides and angles, and we're going to use Sakatoa here, okay? Your key hint is you've got a right angle triangle. Now here, I've got an angle here. I've got my opposite. I've got my hypotenuse. It must be sine. So I'm going to write it. Sine 42 should equal to opposite over hypotenuse. So x is my opposite. 17 is my hypotenuse. To find x, I'll just multiply both sides by 17. Put that in your calculator, and you should get 17 times sine 42. Should get something like 11.4 to 1 decimal place. Next one. Now here I've got, that's my angle. So I've got my opposite and I've got my hypotenuse again. This is another sine. So now I've got sine 32 equals to 4 on x. Now the only difference is here, my x is actually on the bottom. So to solve for x, I'll need to times it across to the other side. Okay, timesing both sides by x means I get rid of it on the denominator on this side and it moves over there. Now to get the x by itself, I now need to divide both sides by the sine 32. So that gives me x equals to 4 over sine 32. And writing that down should give you your answer, which is to 1 decimal place, 7.5. Okay, please round properly. Okay. Now, if I'm trying to find an angle to the nearest minute, I'm going to do the same thing. There's my angle. I've got an opposite side. I've got an adjacent. This must be tan. So now tan theta equals to 12 on 14, because that's opposite over adjacent. In case you're not tracking, tan is opposite over adjacent. And so 12 is my opposite, 14 is my adjacent. And now this is the step here that's a bit different for an angle. If you're finding an angle, you'll need to use this thing called inverse tan or shift tan. So on your calculator, you just press shift 10. And if you go shift 10, you go 12 and 14, should give you your answer. You'll get something, and it says to the nearest minute. So you press this degrees, minutes, seconds button, and you should get something like 40 degrees, 36 minutes, and 4.66 seconds. Now we round it to that number there, we kind of round it to, if it's above 30, we round up. If it's below 30, then we round down. Okay, so in this case here, 4.66 is significantly below 30. So we're just going to keep this as 40 degrees, 36 minutes. Okay. And last one here, we've got a hypotenuse. We've got a adjacent, hypotenuse, and adjacent. That is a cos. So this one here, last one, well done for bearing with me. I'm going to say cos of my angle is A over H. And so again, to find theta, now I would just go shift cos. Once you put that in your calculator, 11 on 19, this gives you 54 degrees, 37 minutes, and 24.46 seconds. So again, rounding to the nearest minute, I just keep it there. And the 24 is not greater than 30. So I'm going to keep it as 54 degrees and 37 minutes. Okay, and that's it. Hope that helps, and I'll catch you guys later. Bye-bye.